Now today we are going to see the laser diffraction experiment, where you are going to determine the wavelength of a given laser light using diffraction. Now the apparatus required is a semiconductor laser, grating element, this is called as a grating element, a meter scale and a screen. Here this is a screen and we have a graph sheet. Now we are going to determine the wavelength of a given laser light using a diffraction grating element. Now we know that laser light is highly monochromatic source of light, and you can see here I have switched on the laser light. The light is allowed to fall on the screen. You can see the intense beam of light on the screen. When there is no grating element placed here, you are getting a direct spot over there on the screen. Now we are placing a grating element on the light so that the light falls on the grating, and you can see the bright spots on the screen. You can see the bright spots. These spots are being observed when the grating element has been placed. This is called as laser diffraction. If you remove the grating, you can see a single spot. If you place the grating in the path of the laser light, you are able to see the grating. This phenomena is called as diffraction grating. Diffraction. Here we are placing the grating element and the light is allowed to fall on it, and there is a meter scale where the distance from the grating element, the center point of the grating element to the screen should be 1 meter, and you can see the spots here. The center one is called the center spot. This center spot is the central bright spot, and as you move away from the center spot, you are able to see the intensity of the light keeps on reduces. Here the intensity of the light keeps on reduces. Now we are going to see we have to take the spots on the graph sheet and focus this on over here. This is the center one. Mark a point here, make an arrow. It indicates the central bright fringe. This is right side first order, this is right side second order, this is right side third order, this is right side fourth order, and this is right side fifth order. Similarly here, make a mark with a pencil. This is left side first order, left side second order, left side third order, fourth order and fifth order. Like this we have to make the spots. Here the diffraction is happening and the intensity of the fringes keeps on reduces as you move away from the center towards right or towards left. So this is the phenomena where we are getting a diffraction because of a diffraction grating element placed in the path of the laser light. We have marked the spots, and now we need to work on this distance of the spots. The spots what we have taken here, remove the graph sheet from the screen and you get the points in this way. Now here the points we have taken on a line and join. This is the center one. This is the central spot where we have got the bright fringe, and towards this is R1, R2, R3, R4 and R5. This is L1, L2, L3, L4 and L5. Now join both left and right first orders. Join the first orders. We have got the point here. Take this first order vertically up, this also vertically up. Join these two. That means both the first orders are been marked and drawn a line like this. Next is both the second orders are been drawn in this way. Third orders are being joined by taking vertical and horizontal line. So you are getting the laser diffraction pattern in this way. Now we start the readings, how to tabulate the tabular column. Now here we are going to measure the distance from the center spot towards right side, this distance, using a scale. Put a scale on the center point, central bright fringe, and note down the reading. Now the reading from the center spot to this is 1.3. Now this reading 1.3 has to be tabulated in the tabular column. This is the tabular column for the laser spots. Here the order of M indicates order, first order, second order, third order, fourth order and fifth order. Now here Xm is the distance from the central spot. This is right side reading and this is left side reading. Just now we have measured the distance, right side reading, it is coming as 1.3, which is in centimeters. Similarly, measure the distance towards the left side, first order, measuring, it is coming again, it is 1.3. This distance, the distance from here to here has to be measured, from here to here, this distance. Either you can measure like this and make it as 1.3, or for your convenience, if you want, you can do in this way also. This also comes to be 1.3. The value has to be taken. The distance is from here to here, it is 1.3. So left side also we are getting 1.3. So the same thing towards left hand side, I am tabulating it as 1.3. This is the first order towards left and this is first order towards right. Now we go with the second order. That is, for the second order, distance from the center spot to the second order spot. Now we are going to measure the distance to the second order spot. That is, from here to here, it is 2.6. Similarly, measure towards the left hand side of the second order and tabulate the reading. Now towards left hand side we got it, towards right hand side we got it as 2.6. Similarly, I measured it, you are getting it as 2.6. Now we are going to see for the third order. Now measure the distance from the center spot to the third order, it is coming as 3.9 towards right side, and similarly you measure for the left. Now tabulate the reading here as you are getting as 3.9 towards right side. Complete the remaining tabular columns by measuring it. Now we have got the readings from the spots. The tabular column has been filled by the way how we have filled for the first order, second order, third order. So these are the readings. Now the next column is take the average of left and right. This is in centimeters. We are going to see we convert into meters. They take the average. L plus R by 2 means 1.3 plus 1.3. Take the average of these two. You will be getting the value of 1.3 into 10 to the power of minus 2. Next, here both are same, so I will write it as 2.6 into 10 to the power of minus 2. Take the average and take the readings. Now after taking these values, next column is to determine the wavelength lambda using the formula. For this formula, d value of d is given constant value, the diffraction grating constant, it is given 2.54 into 10 to the power of minus 5, and the distance from the screen to from the diffraction grating element to the screen, we have kept it as the distance from the grating element to the screen, we have kept it as 1 meter or 100 centimeters. So it become 1 meter. So we need to substitute the value of Xm. The value of Xm is here. Substitute these values into this formula. Now we are going to see the calculations here. The value of d is given 2.54 into 10 to the power of minus 5 and d is 1 meter. This is a formula which we are going to use. 2 into small d is the grating constant. This is the constant value. M is the order for which you are calculating. D is the distance from the grating element to the screen. It is 1 meter, and Xm is the one which we have got it from the values. Now here we are doing for the first order. For the first order we are going to calculate the wavelength lambda using the diffraction element. So M should be taken as 1 in this case. Now substitute the values here. The grating constant 2 into d by m value is 1 first order, and Xm we have got it as 1.3 into 10 to the power of minus 2. Substitute the values in the corresponding places, and if you do the calculations, capital D is given here XM is given here. Do the calculations, the whole thing it will come with as 660 into 10 to the power of minus 9 meters. So we can write it as 660 nanometers. This is the answer for the first order. Now write this value into this as 660 nanometers. Similarly, you have to do the value of lambda for the second order. Substitute in this formula. We have got all the values here. Instead of 1 for the first order, now you are going for the second order. So substitute value of m here as 2 when you are doing for second order. Substitute the value of m as 3 for the third order, and this value is except. Substituting in this formula, we need to calculate the values of lambda. Now using this formula for different order, and these are the values of xm for different orders. Substitute in this formula corresponding orders. You need to fill this column, and you are getting almost consistent wavelength of the light of a given laser. Take the average of these and write the value as here as the wavelength of a given laser light is 660, approximately 660 nanometers. So this gives the result. Use the wavelength of laser using a laser diffraction.